Instinct is often called the wisdom of the species. Forged through millions of years of evolution, it allows animals to react instantly to the world around them. Long before learning or reasoning can intervene, instinct guides creatures to find food, avoid predators, reproduce, and care for their offspring. In many ways, instinct is one of nature's most powerful survival tools. But consider a troubling set of questions. Why does a moth fly straight into a flame? Why do newly hatched sea turtle hatchlings sometimes crawl toward the highway instead of the ocean? Why do living creatures occasionally bring about their own death because of the very instincts meant to protect them? Surprisingly, instinct does not always serve survival. Under certain conditions, it can fail, and sometimes fail catastrophically. The reason is simple. Instinct is not flexible. It is a fast, hard-coded response shaped for a particular environment and a particular set of signals. When those signals change, become exaggerated, or collide with one another, the system that once ensured survival can turn into a deadly trap. To understand why this happens, we can examine several situations where instinct backfires, revealing the hidden vulnerabilities of one of evolution's greatest inventions. Many instincts evolved to respond to specific environmental cues. The stronger the cue, the stronger the response. But when humans artificially exaggerate those cues, instinct can lose sight of its original purpose. Biologists call this phenomenon a supernormal stimulus. The classic example involves moths. At night, moths navigate by maintaining a constant angle relative to distant celestial light sources such as the moon. Because the moon is extremely far away, keeping a fixed angle allows the insect to fly in a straight line. Artificial lights, however, break this system. The nearby candle or light bulb appears far brighter than the moon when the moth attempts to maintain the same navigation rule, keeping a constant angle relative to the light. It unknowingly begins to spiral inward. Instead of flying straight, it circles closer and closer to the flame. Eventually, it collapses from exhaustion or burns. The instinct itself has not malfunctioned. It's doing exactly what it evolved to do. But the stimulus has been artificially amplified beyond anything the natural world ever produced. The survival mechanism has been hijacked. Instinct evolves slowly. It is calibrated over thousands or millions of generations to match a relatively stable environment. But modern environments can change far faster than evolution can keep up. Biologists refer to this mismatch as evolutionary lag. A striking example appears again in sea turtles. For millions of years, newly hatched turtles emerged from their nest at night and instinctively crawled toward the brightest horizon. In the natural world, that brightness came from moonlight reflecting off the ocean. This simple rule reliably guided hatchlings toward the water. But today, many coastlines are illuminated by cities, hotels, and street lights. Instead of the ocean, the brightest horizon may now lie inland. As a result, thousands of hatchlings crawl away from the sea toward roads, buildings, and parking lots where they die from exhaustion, dehydration, or predators before ever reaching the water. The instinct itself remains unchanged, but the world it evolved for has disappeared. A similar problem affects many insects. Female butterflies evolved to recognize chemical signals from plants that would safely feed their larvae. Yet, pesticides and invasive plants can transform these once reliable signals into deadly traps. The instincts still function exactly as designed, but the map no longer matches the territory. Instinct can also fail when multiple powerful drives activate at the same time. When two instincts demand incompatible actions, the animal may experience a form of behavioral conflict. In some cases, the nervous system resolves this tension through what ethologists call displacement activity. Imagine a lioness encountering a threat while caring for her cubs. Two powerful instincts immediately activate. One is the maternal drive to defend and protect her offspring. The other is the instinct for self-preservation, the fight or flight response. Both systems demand action, but in different directions. When neither response clearly dominates, the nervous system can momentarily stall. Instead of fighting or fleeing, the animal may suddenly perform an unrelated behavior, yawning, grooming, scratching the ground. To an observer, the lioness may appear calm or indifferent. In reality, her behavioral system is momentarily overwhelmed. This brief hesitation, an instinctive system crash, can provide predators with the opportunity they need. Individually, instincts function remarkably well, but when they collide, the result can be confusion rather than clarity. These failures of instinct may seem like animal stories, but humans are not exempt. Deep within our brains lies the same fight or flight response that once helped our ancestors survive predator attacks. When danger appeared, the body rapidly increased heart rate, redirected blood to the muscles, and prepared for immediate physical action. In prehistoric environments, this response was life-saving. In modern society, however, most threats are not physical. Deadlines, financial stress, and workplace conflicts cannot be solved by running or fighting. Yet the brain often reacts to them as if they were predator attacks. The result is chronic stress. When the fight or flight system remains activated for long periods, it contributes to anxiety disorders, panic attacks, hypertension, and cardiovascular disease. An instinct designed to protect the body in short bursts becomes harmful when triggered continuously. Once again, the instinct itself is not defective. It is simply operating in an environment very different from the one in which it evolved. Instinct is one of evolution's most remarkable achievements. It allows animals, including humans, to respond instantly to life or death situations without conscious thought. But instinct is not universal wisdom. It's a specialized tool shaped for specific environments and specific signals. When those signals are exaggerated, as in supernormal stimuli, instinct can be hijacked. When environments change rapidly, as in evolutionary lag, instinct can become outdated. And when multiple instincts collide, the system itself can stall. The same mechanism that once guaranteed survival can, under the wrong conditions, lead organisms directly toward danger. This does not mean evolution failed. It means instinct is context dependent. True wisdom may lie not in blindly trusting our instincts, but in recognizing their limits and learning when to question them in a world that is changing faster than evolution ever anticipated. Thanks for watching. If you found this video helpful, give it a thumbs up and don't forget to subscribe to the channel.